Hi, so this week's challenge was to identify an unknown organic compound using an IR, 1H NMR, and a 13C NMR spectra to identify. This was the following spectras that we received. So here we have the IR spectra. Let me try to get the whole thing in one frame. And then up here we have the 13C spectra, as well as our compound right there. And then lastly we have the 1H spectra. So the first part of the worksheet asked us to notate the molecular formula. So that one was pretty easy. That was a given, as we noticed from the spectra worksheet. So I just wrote down C6H12O2, and then we had to calculate the degrees of unsaturation. So just looking at this first part, to calculate and get an idea of the compound structure, I use the original formula. Degree of unsaturation equals parentheses 2C plus 2 minus H, close parentheses, divided by 2. And then pretty much long story short, and you can also look at the notated equation right there as I work through it, but we got 1 degree of unsaturation. So when we do have 1 degree of unsaturation, that speaks toward like a double bond or a ring being present. So this kind of clues us in that there might be a carbonyl group potentially involved, which we definitely found in the 13C NMR spectra as well. So as we sort of kind of go through working through all of like these points, I guess we can go over like some key things that we see here. The first one that we can go over is in the IR spectra with the peak highlighted at around 1,735 centimeters, -1. We notice that this is kind of typical for a carbon double bonded to oxygen stretch, which is noted in esters. And then on this same spectra, I just highlighted that little cluster of peaks between 2,850 and 2,980. This shows a carbon single bonded to hydrogen stretch, which is a characteristic of an alkyl, confirming like a hydrocarbon backbone. Also importantly that I noted on here is that we notice there is no 3,300 stretch, so there's no broad like OH stretch in that region, so we can rule out it being an alcohol or a carboxylic acid. So now I would like to consider this spectra right here. This is the 13C NMR spectrum, and the first peak that we can kind of focus on is highlighted. We could call that like 172. This confirms a carbonyl carbon, which is typical of an ester again. So we're seeing that ester trend. There's also a peak at 60 right here that is notated. This likely corresponds to a CH2, which is bonded to an oxygen, again kind of supporting the ester presence, and this is likely speaking toward an ethyl ester group. Then in the 13C NMR spectrum, I'd also like to focus on this like general area here. The remaining peaks, they fall between 10 and 40, so that speaks towards like different types of alkyl CH2 and CH3 groups. So that's the ideas that we get from these two spectras. So starting off with the 1H NMR spectrum, I'd like to first focus on this peak right here. I tried to highlight like how you can see that it's a quartet. This quartet is present at 4.1. So this kind of translates to 2 hydrogens and suggests a CH2 being next to an oxygen. This would be similar to like an OCH2 group. So we can also kind of take that into consideration. Right next to it, so I accidentally highlighted this one, but we're gonna focus on this tall one. So right next to it is a triplet at 1.2. This is integrating for 3 H's. This is a classic trait for CH3 next to CH2, which would complete the ethyl group of an ester like we previously took into consideration. Something else that's kind of notable is the triplet here at 0.9. This is integrating for 3 H's, or 3 hydrogens, sorry. This kind of speaks toward being a terminal methyl on the chain. So those are all good traits to kind of consider as we, like I guess, identify this organic compound. So now that we sort of charted the chemical shifts and frequencies, in addition to the functional groups, bonding environments, integrations, and multiplicities, and sort of speaking toward their interpretations as well, it is clear that the IR spectra sort of kind of translates to being an ester. Then as we go down, the 13 CNMR spectra matches with 6 unique carbons, including 1 carbonyl and an oxygen-bound carbon. And then traits to consider that we gathered from the 1HNMR spectra is that we pretty much got a clear layout of it being an ethyl ester group, and this also showed us that there was a 4-carbon butyl chain. So based on all of the spectral evidence, the compound is safe to say that it is ethyl butanoate, and this is the compound written out. And again, that's the molecular formula. And then here's the proposed structure. It's safe to propose this as a structure because it is an ester functional group. The CH2s are near oxygens, and there are multiple alkyl signals. And all the data from this is represented in here. Also, again, the degree of unsaturation sort of clued us in that there was going to be a double bond somewhere. So that oxygen can kind of take on that load right there. Thank you for watching my video. This is sort of how I used all of the information from the spectras provided to navigate toward like sort of proposing the structure and identifying the compound. And thank you for a great semester. Have a great day.